Good afternoon, fellow maths doers. Today we're going to be talking about a concept which has given me more headaches than the exponential function has derivatives. That's right, we're talking about the reverse chain rule. Now you'll notice it's in inverted commas because I don't like calling it the reverse chain rule because it kind of implies that you can use it in any instance where you might use the chain rule, which is just simply not the case. So today we're going to talk a little bit about what it is and how it's misused, but I think it's best explained by just getting straight into some examples, which we'll do in a second. Now on your formula sheet, you'll notice the reverse chain rule looks something like this. If we have the integral of a function ax plus b all to the power of n, that's going to equal ax plus b to the n plus 1 all divided by a times n plus 1. Now, if you're unfamiliar with the chain rule or you haven't really seen this before, this may look quite arbitrary, but, plus c, whoops. But you'll notice that if you differentiate this function on the right, then you will get the function that we're integrating on the left, which is the very definition of integration. It's the antiderivative. So if we look at this, d on dx of ax plus b to the n plus 1 on a times n plus 1 plus c. Well, the plus c is going to simply disappear because it's a constant. And then the derivative of this, well, this on the bottom, these are all constants as well. So we can sort of just bring these out the front, and we're not really going to have to deal with these so much. They're just a scale. They're just multiplying the function of x by something. So we'll just ignore these for a second. These are just constants. This function here, ax plus b to the n plus 1. Well, if you're familiar with the chain rule, you know that you take this n plus 1 up here and you bring it out the front. So we get n plus 1 times ax plus b. And then we want to decrement this power. So it's going to become ax plus b to the power of n, or n plus 1 minus 1, which is n. And then we can't forget we have to multiply by the derivative of this function in the middle, times a. If any of that sounds unfamiliar, then go back and watch the video on the chain rule, because that should make sense if you understand the chain rule. And so now, with some very simple cancellation, we can sort of see the a cancels here, the n plus 1s cancel, and we get ax plus b to the n. So by differentiating the answer, we get the thing we were integrating, which means that this integral is correct, right? Now, the common misunderstanding with the chain rule is that you can do it even when this inner function's not linear. And when I say this inner function is linear, what I mean is it's in the form linear function is y equals, in this instance, ax plus b, right? This is the gradient and this is the y-intercept. Yeah, a linear function, it's a straight line if you graph it on the Cartesian plane. The problem is we can't actually do this with any function that isn't a linear function, and I'll explain why right now. So imagine we have, let's move that up a bit. Imagine we have some function of x to the power of n, right? And we want to integrate it. Then we'll go, okay, by this logic, we'll go f of x to the power of n plus 1, and then we'll just divide by the derivative, because that's all we did up here, was we divided by the derivative of the inner function, which was a, and then also divided by n plus 1, right? And so this seems like it would work because it's following the exact same logic as we did earlier. But the problem is, if we want to differentiate this, right? And this function of x isn't a constant, so it's not just a, right? So if we differentiate a linear function, we're getting a constant. But if we're not differentiating a linear function, then we'll get a new function in x, which isn't constant. And that's our problem, right? So let's say, for example, we were doing derivative of sine x to the power of 3, right? And we said it was equal to sine x to the power of 4, all divided by 4 times cos x plus c. Looks like it might be right. Yeah, seems fair. Same logic. Problem is, what happens when we try and differentiate this, right? We can't simply go, that's the d on dx of sine x to the 4 on 4 cos x. That's not equal to sine cubed x, because we have to use the quotient rule, right? As soon as we have a function of x on that denominator, we've got two functions, one divided by the other, and we have to use the quotient rule if we're going to be able to solve that, right? So this doesn't hold, and you can't do this at all. And this is simply not true for any function. It will only work if that inner function, that thing that you've got to a power, is linear, yeah? So with that in mind, let's get into some examples. We'll start with a couple of questions that will look familiar if you did the Catholic trial. This question here looks a little bit complicated, but if we convert it, x plus 1 on x plus 7 cubed is actually just x plus 7 to the power of negative 3. Right? And so now, quite clearly, we can use the reverse chain rule in this instance because x plus 7 is a linear function. So we'll go, that's equal to, now I've got to make sure I don't get it wrong here. So if we increment negative 3, we get it up to negative 2. So we'll go x plus 7 to the power of negative 2, all divided by negative 2. And now this a from the original, you'll notice in the original equation we have to divide by a because that's the derivative of the inner function. But the a in this case is just 1, so it's just negative 2 times 1 plus c. So it's just x plus 7 to the negative 2 on negative 2 plus c. And if you're going to be a stickler about it, that's x plus 7, negative 1 on 2x plus 7 squared plus c. A mistake I'll see made very often here is instead of incrementing negative 3 to negative 2, people accidentally decrement it down to negative 4, thinking they're increasing it, when really that's decreasing it because negative 4 is smaller than negative 3. Okay, moving on. This is another question that was in the Catholic trial. Find the volume when the shaded region is rotated about the x-axis. So it's between x equals 0 and x equals 1, and under the curve y equals e to the x plus 1. So if you know how to do a volume when a curve is rotated around the x-axis, you'll know that it's v equals between b and a, y squared dx. In this instance, between 1 and 0 of e to the x plus 1 squared dx. And now we see we have an equation, a function of x to a certain power. And this is the exact sort of situation where it looks like you might be able to apply the reverse chain rule, but you really can't. So what we actually have to do in this instance is we have to expand it, yeah? So that ends up being between 1 and 0 of e to the 2x plus 2e to the x plus 1, which is between 1 and 0 of 1 on 2 e to the 2x plus 2e to the x plus x between 1 and 0, which is going to be a half e squared plus 2e plus 1 minus a half minus, sorry, I'll put it in brackets, minus a half plus 2 because e to the 0 is just 1. So, and then we'll simplify that. We'll get half e squared plus 2e minus 1 minus 3 on 2. Easy as, right? And just to really ram home that point, if instead we tried to do this the wrong way, I'll put it in red because it's red for wrong. If we tried to do this the incorrect way, what's going to happen is we'll go between 1 and 0, e to the x plus 1 all squared, which is equal to between 1 and 0. And you might say e to the x plus 1 all cubed on 3e to the x or something like that. And you'll just see these are completely different answers, and this one's just very incorrect. And again, if you tried to differentiate this function here, you'd have to use the chain rule, and your answer would be completely different from the original function, e to the x plus 1 squared. So this is a big no-no. This is incorrect. Okay, and for one final question, this one's not too tricky, especially with reference to the first one. This is from another paper. 1 on 2x plus 3 squared dx. Well, we know we have to convert that denominator power to a numerator negative power. Boom, boom, boom. There we are. And then we'll go increment this because we're integrating. It'll be negative 2x plus 3 to the power of negative 1. 2x plus 3 to the negative 1 divided by this new power negative 1 times the coefficient of x, which is 2, plus c, which is just negative 1 on 2x plus 3 plus c. We might simplify that just to make it nice and finished. Negative 1 on 4x plus 6 plus c. All right, I hope you guys found this one helpful. Try to avoid making mistakes with that reverse chain rule in the future. Let me know if any of this isn't clear, and I'll see you next time.